Alright, in this section we will be using the inverse Laplace transform to convert numbers given in s coordinates into t coordinates. And the best way to show this is to just start with an example. So let's do number 8 on the Pearson homework. Number 8 will be similar for you, so we get negative s squared minus 3s plus 2 over s plus 4 squared times s plus 3. Let me write that a little bit clearer. There we go. Alright, well, to do this, we really don't have a formula that we can use. Most of the time we're going to be using properties and other manipulative methods to reduce these into formulas as seen in the chart in section 7.2. But obviously we cannot do that with the given information. So we're going to actually have to do a partial fraction. So we're going to have negative s squared minus 3s plus 2 over s plus 4 squared s plus 3 is equal to, well, we're going to have a s plus 4, but remember, since this is squared, we also have to include a b s plus 4 squared, and that's because it's a repeating factor, plus c s plus 3. Now we multiply across, and we get negative s squared is equal, minus 3s, that's better, plus 2 is equal to a of s plus 4 s plus 3 plus b b s plus 3 plus c s plus 4 squared. Because we're multiplying by the common denominator, and this is what's left remaining. Okay, so now what? Well, we got to solve for a, b, and c. I think the best way to solve for a, b, and c is start by finding b. And to do this, we're going to do s is equal to negative 4. And when s is equal to negative 4, this cancels and this cancels. So we get negative 4 plus 3, we get negative b is equal to, when you put in negative 4 over here, you will get, well, let's see here, you'll get negative 16 minus 12, so negative 28. Oh, that can't be right. Let's see here, what are we, negative 4, so we get 16, negative 16, plus 12, so negative 16 plus 14 is negative 2. That's better. B is equal to 2. Alright, now we can solve for, let's solve for C. So s is equal to negative 3. So when s is equal to negative 3, this cancels and this cancel. And we get C. And negative 3, we're going to get negative 9 plus 9, so 0, 2. C is also going to equal 2. And now to solve for A, well, we'll just say, we'll collect the s squared terms. So we're going to get A plus C is equal to negative 1. Because the negative 1 is in front of the s squared term. So a plus c, well, we have c too, so a is going to equal negative 3. So a equals negative 3. And we have our thing. So usually in Calc 2, I'm going to rewrite it here. Usually in Calc 2, we would integrate. But our goal isn't to integrate here. our goal is to find the inverse Laplace transform. So we're not going to integrate. What we did was we split this up into a couple of terms that now we can use the charts to solve. So we have negative 3 over s plus 4. So looking at our chart in 7.2, we see that negative 3 over s plus 4 matches the e to the alpha t function. So alpha would be negative 4 because we have a double negative there, right? So we get negative 3 e to the negative 4t. And that's negative again because in the chart it's s minus a. So since it's plus, this would have to be a negative. So we have e to the negative 4t times by negative 3 plus 2 s plus 4. Well, this follows the e to the alpha t tn, where t would be 1 because this term right here, the squared, s plus 4 squared, is s plus 4n plus 1. So t would by default be 1. So we have t times alpha. Alpha is again negative 4 because we have a double negative. Alright, and finally we have this. So we're going to have t, s plus 3. This is again the e to the alpha t. Alpha would be negative 3 because we have a double negative here. So this would be the Laplace transform of the function. So for this problem, we have 4s squared plus 57s plus 289. Oops. 289 over s minus 1 times s squared plus 8s plus 41. Alright, so we need to do a partial fraction, so I'm going to set that up. A over s minus 1. But for the second term, we're going to need to factor the denominator using completing the square. So doing that, we're going to have s plus 4 squared. That gives us s squared plus 8s, which we have, plus 16. So we need to take 41 minus 16, and that gives us 25. 25. Now on the top, since we completed the square, we have to do this kind of a strange modification of partial fractions, where we just take b times this term, s plus 4, you omit the squared, plus c times this term. Well, this is just 5 squared, and we don't want the square, so it's going to be 5. Alright, and that's the trick to this problem. After this, it kind of turns into just a regular partial fraction. So the first thing you do is you multiply both sides by this denominator. And rewriting, you get 4s squared plus 57s plus 289 is equal to a times, well, s squared plus 8s plus 41 plus, well, this is going to cancel, and we're going to be left with b, s plus 4, s minus 1, and c, 5c rather, plus 5c, s minus 1. Alright. Well, we can use s equals 1 and that'll leave us with this term. So we have 1 plus 8, so that's going to be 50a. And when you plug in 1 over here, you're going to get 350. 350, 350, or 350 divided by 50 is just 5. So a is equal to 5. Alright. Oh, nope, that's not right. I'm sorry, it's 7. 7. Alright. Now what should we do? Well, I think we'd be best off if we group the s squared terms. So, we have 4 is equal to any term that has s squared. Well, there's an s squared, so we have a. And if we distribute this, we'd get plus b, because that'd be s squared. And that's it. And we know a is equal to 7, so 4 minus 7 is negative 3. b is equal to negative 3. And finally, we got to solve for c. I think the best way to solve for c would just be to group the s's. So we have 57 is equal to 8a. Negative 1 plus 4 is 3, so plus 3b. If we expanded that, we'd be left with 3b. Well, 3sb, but again, we're grouping by s's, so we omit the s. And then plus 5c. So we're going to be left with 57 is equal to 56 minus 9 plus 5c. Now I'll grab my calculator, and we get 57 minus 56 plus 9 divided by 5. C is equal to 2. Okay, so we solved for our 3 coefficients. Now we just plug back in, and we get 7 over s minus 1 plus b. Well, b is negative 3, so we have negative 3 s plus 4 over, and now I'm going to split this fraction. I'm just going to say this over this plus this over this is the same as all of this grouped over together. Nothing complex. So s of 4 squared plus 25 plus, and now 5 times 2 is 10 over s plus 4 squared plus 25. Alright, moving on. Now we're going to need our inverse Laplace transform little cheat sheet from 7.2, which I actually don't have with me here, so let me grab. There it is. So we got 7 s minus 1. Well, that's going to be e to the alpha t. So we're going to get 7 e to the 7t. Or e to the regular t. I'm sorry, just 1t. Because alpha is 1. Minus 3. Well, this is going to be the last property. And we're going to be left with e to the negative 4t. Or Laplace transform rather, e to the negative 4t cosine 5t. And then, of course, this will be the second to last property, e to the alpha t sine beta t. And, well, let me kind of write this here. So we have 10, but we need beta in the numerator. So for this to equal 10, we still need to divide by 5. So 10 divided by 5 is 2. So we will end up with, well, I'll erase this, but I'm just kind of showing you where the 10 divided by 2 comes, or 10 divided by 5 comes from. 2 sine 5t e to the negative 14. And that will be the answer. Alright, so this will be our last partial fraction example for this section. This is the same as number 10 in the online homework. So we're going to have 7s cubed minus 12s squared minus 5s plus 10 all over s cubed s minus 2. And now to expand this, well, we have a repeating factor there, so we're going to have a over s plus b over s squared plus c over s cubed plus d over s minus 2. Not too bad. Okay, so we're going to multiply by this denominator here, and we're going to get 7s cubed minus 12s squared minus 5s plus 10. And over here, we'll be left with a s squared s minus 2 plus b s minus 2 plus c s minus 2. I'm going to run out of room here, so I'll just put it down here, plus d s cubed. Okay. So if we plug in 0 for s, we're going to be left with the c term. Yep, and we're going to get negative 2c is equal to 10. And c is equal to negative 5. And then if we plug in 2, we're going to be left with s cubed. So 2 times 2 is 4 times 2 is 8. So we have 8d is equal to, let's plug this in here, 2 cubed times 7 minus 12 times 2 squared minus 10 plus 10. And we're going to be left with 8, and we get d is equal to 1. Alright, and now let's group the s cubed terms. So we're going to have 7 is equal to a a plus d. A plus d. And d is 1, so a is equal to 6. And then finally we need a, well, we have a, we have d, we have c, we need b. Okay, so for b, let's solve for s squared. So we have negative 12 negative 12 is going to equal negative 2a plus b. Okay, and again, a is 6, so b is actually going to equal 0. So that's good. One of our terms is going to factor. So, don't want to move this. Let's move this over here. So we have 6 over s, 0 over s squared, minus 5 over s cubed. And where's our d? D is equal to 1, so plus 1 over s minus 2. Okay, and we're just going to find the Laplace transform of these. 6 over s is just going to be 6. 5 cubed here is going to end up being 5 halves, well, negative 5 halves, t squared, plus 1 minus s minus 2, that's going to be e to the 2t. And that is the Laplace transform for this. Now for the next two problems in this section, we will use some properties to solve some a little bit harder Laplace transforms. Okay, so we have two problems here that we're going to solve using this property. And rather than trying to explain the theory of it, I think it will make more sense if we just jump right into an example. So for here, for the first one, this is the same as number 11 on the homework. We have ln s squared plus 81 divided by s squared plus 4. So the first step we want to do is we want to put this in a form where we can take the derivative of it. And to do that, we use log properties to subtract the two. Ln s squared plus 4. Alright, now we can take the derivative of this. So if we take the first derivative, n is equal to 1. If we take the second derivative, n is equal to 2. Third derivative, so on. For this problem, I think it will be best if we find the first derivative. So due to the chain rule here, we'll have 2s over s squared plus 81 minus, again, the chain rule, 2s s squared plus 4. And this is going to equal negative t to the n. N is just 1, f of t. And again, this is just this property where it's saying we can take the derivative of this function n amount of times and set that equal to negative t to the n times f of t. And by doing this, we can solve a lot of Laplace transforms. But in this case, we only had to take one derivative because we know how to take the Laplace transform of that. So we get 2, and this is going to be cosine 90 minus 2 cosine 2t. But remember, this is still equal to negative t f of t. And we're solving for f of t, so we need to divide by negative t. And we're going to get 2 cosine 90 minus, 2 cosine 90 minus 2 cosine 2t over negative t is equal to f of t. And that's our inverse Laplace transform right there. Nothing too bad. Let's move on to number 12. Number 12 is a little bit more tricky, but only because it's an inverse trig, but again, not too terribly bad. So number 12 is tan inverse 10 over s. Alright, and now to take the derivative of this. Well, we're going to use our derivative sheet, and we get the derivative of this is 1 over 10 over s squared plus 1. And now, since this is a chain rule, we need to take the derivative of the inside, and that's just negative 10 over s squared is equal to, again, we're using that property, so we took the first derivative, so it's negative t to the n, which is just negative t, times f of t. Alright, this is multiplied. Well, multiplying this, we're going to get negative 10 over the s squareds will cancel here, and we're going to be left with 100 plus s squared is equal to negative t f of t. So, dividing by negative t, we get 10 nope. Sorry, we don't want to do that quite yet. We wanna solve the inverse Laplace transform of this. Well, the inverse Laplace transform of this is just negative sine 10t. Okay, is equal to, well, sorry, negative, negative, wait. Oh, the 10 cancels because beta is 100 and that's 10. So the 10 will cancel and we get sine 10t is equal to negative t f of t. Um, and now to solve for f of t, we need to divide by a negative t. But their negative is still there, so these are going to cancel. So we have sine of 10t over t. So a little bit tricky, but all in all, not too bad. And that concludes section 7.4.